Welcome to another installment of Fortnightly Coding Problem, where basically the idea is, every fortnight we kind of jump in and we choose a problem for, from Daily Coding Problem, right? So it's Daily Coding Problem just taken out to a fortnight. So this week we're having a little look at problem 47 from Daily Coding Problem, where we kind of need to, calculate some. Basically, we're investors for the fortnight. We're going to be Wall Street investors, and we're going to try and get the best price. This week, or rather this fortnight, what we had to do is basically we get a list of stock prices, and we've got to calculate the max price. Now, kind of looking at the problem, the first thing I kind of do when I'm kind of get these problems is I think, all right, first thing, have a crack at doing an example, right? So we can see here that we're given these share prices, and we know we should return 5 as the maximum profit we could get from buying a share and then selling the share later. So first things first is like, all right, can we just run through the example and make sense of why in this case is it 5 as the profit. Once we can do that, maybe that might help us to have a little bit of intuition into how would we have a general solution for any set of any kind of sequence of prices over time. Once we've got the example down pat, then we're thinking okay, cool, got the example, that's great and all, but can I just come up with a very the naive solution, kind of the first kind of crack at it. And it might be a brute force solution, but you definitely take just a solution over no solution, right? It's a little starting, kind of first running a ladder. We might just, have that as the kind of initial attempt. Once we've got that, then we can think all right, maybe your solution was, quadratic in time. And you think, well, actually, I just noticed there's kind of this, certain, property of the question that I might be able to exploit that and get that down, to log n time or even linear time, right? So that's kind of our initial point, and then we might have an optimized solution. And then lastly, it's have a gaze at the solution, because if you look at the solution, right, there might be the way they might approach it completely differently, right? And so you can learn a lot from just seeing how other people how to crack at it. So enough of me going on. Let's just jump in, right? Let's get day trading. So what I've done is I've taken this example and I've just thrown it into Figma, and just so we can come play around with the example. So we've got this kind of axis representing kind of time, and we've got the 6 share prices. So they basically told us that given this example, the maximum profit is 5. So we can kind of see pretty quickly how we could get 5 by buying at t equals 4, right, the 4th share price, and selling at t equals 6, the 6th share price. That would be a profit of 5. But just looking at that there, already we can tell that the buy price has to become before the sell price, right? You've got to buy a share to be able to sell it, so that makes sense, right? So it wouldn't make sense for me to say first you sell at 10 and then you buy at 5, right? You've got to buy first and sell. So we expect to see the share you buy has to come before the share you sell. And interestingly, 5 was the lowest price of all these prices, but I'm going to think that that's not necessarily always the case. So looking at that, it doesn't really come to me straight away a potential solution. But one thing we could do is we could just think, all right, what if we just compared all possible prices, right? So we compared 9 and 11, then we compared 9 and 8, 9 and 5, 9 and 7, as in if I bought a share at 9 and then I sold at 7, what profit would I get, right? If I bought a share at 9 and I sold at 10, what profit would I get? Then go on to 11 and 8 and do the same thing, and basically find which pair of numbers yields the greatest profit. Right, and this kind of comes back to my last point before, is that we can't just do any number, right? You can't say 10 and 7, right? Buy at 10, sell at 7, because 10 comes after 7, which means you could only sell at 10 rather. You know, you can't. There's kind of the strict ordering on these numbers. So we might say something like this: if I can just kind of have a pair of numbers and say 9, 8, you know, and I kind of can keep doing all these pairs, and then I will say, like, you know, 11 and 8, 11 and 5, 11 and 7, 11 and 10, and then move along 8 and 5, 8 and 7, right, and get all those combinations. I can just go and check, you know, which one out of all the possible solutions, which one is the correct one. That kind of, you know, another way of saying that is, hey, there's going to be a pair of numbers here which you need to buy at and then you need to sell at, right? So we know that the solution is going to look like, you know, buy price, sell price, right? So if we're kind of looking at the solution, we know the solution is going to have that shape, right? Where buy price is going to be some number and sell price is going to be some number. And that number is going to come from, you know, the buy price is going to come from here and the sell price is going to come from here. So you can think of it like, well, I want all possible combinations where I've got a buy price and a sell price from this list of numbers, but with the condition that the buy price has to be less than or equal to the sell price in terms of where it falls. If that doesn't make sense, don't worry, because I think hopefully that will kind of come out as we kind of, you know, write this solution up. So let's jump into actually implementing this. So what I've done is I've just set up. Maybe I'll just open up a tab to give us a sense of what's going on. So I'm in this directory called problems. I'm looking at 47, and I've just set up a test for my attempt. You can see, Damo and Dave have already beat me to it. So let's have a look. So I've just set up a test. I'm going to test this function called solution, which I'm requiring from my attempt, right, stocks chem, and I'm just going to call solution with the array of prices, and I expect that to equal 5. So that's just pulling the example straight out of daily coding problems. So now if we run that, so look, it should fail, right? That's what we want. Fingers crossed it fails, and yeah, sweet. Expected 5 to equal undefined, and it's undefined because I'm not returning anything here. So, okay, interesting. So what do we want to do? Well, we can say solution gets a list of historical prices, where historical prices could look like, in this case, that. So I've defined this function called max profit, which, given a list of prices, returns the maximum profit you could earn. So, you know, I kind of said it'd be really nice if we had something like for const combination of it's kind of like buy sell combinations on the prices. You could say something like let max equal math.infinity, I think it is. And basically, we just want to go through and want to find so of each combination, right? And let's just say it's an array with a buy price and a sell price. So buy price, sell price. And we would say, okay, well, profit is just going to be our sell price minus our buy price. And if, well, actually, what we can do is we can say max equals math.max, our current max, or our profit. Maybe we'll say max profit. We'll say max profit let's just call it max. Great. So that's kind of the brute force solution. So we're kind of thinking, hey, if we had some function called by cell combinations, which function by cell combinations will take prices, right? And we kind of expect by cell combinations to return us something like a list of like, what do we have? 9, 11, 9, 8, 9, 5, right? So it's going to give us all possible combinations of buy and sell prices, and then what we're going to do is we're going to take that. I'm going to calculate the profit, right, which is just what did you sell it for, minus how much you buy it for, and then see if that particular profit is the greatest we've seen so far. All right, so now that we've got, we've kind of got this idea of, this buy and sell price, which is going to be, buy sell combinations is going to do the hard work for us. The next thing we have to do is, well, we need to implement buy sell combinations. So how do we implement buy sell combinations? Well, you can kind of think of it like this. We're going to have to use an old school kind of for loop so that we can, implement this. But basically the idea is we're going to have, one loop variable called I, which is going to kind of iterate over each price in the list. And at each price, we're going to have a nested for loop, right? With j is the kind of loop variable, which is going to start at one after the price, and is going to go and grab essentially the sell price, for each combination. So you can think of I is going to go and grab all the buy prices, and then for each buy price, we're going to set j to go and iterate over the sell prices. So by that, if we kind of take that and kind of chuck it into JS, what we're really saying is that we're going to have we're going to say the old school for loop. It's making a return. So I starts at 0, prices dot length. We do this, play this old game. All right, so that's going to iterate over all our prices, and then for each price or buy price, we want to kind of jet off just one in the future and look at all the potential sell prices. So while j is less than prices dot length, if I can spell. And we're actually just going to make this a generator, right? So instead of computing all the combinations at the start, we're just going to kind of lazily yield them as we need them. So we're going to say where are we? Prices. So this is going to have an array where the first element is the buy price, the next element is the sell price. We yield those off. And I'm just before we kind of just kick it off, this math.infinity, I'm just going to see if that is a thing. Infinity, math, infinity, JS. Infinity, sweet. So we can just say, so we want to start with minus infinity, right? The reason for that is we want any price greater than minus infinity to be our max profit. And to be honest, we want 0, right? Because if we were to calculate a minus, right, if the best we could do was -2, we'd just say, well, don't do it, right? If you can't make any profit, then that profit's 0. So we'll set max to be 0. And it's running. So I'm going to we're running the Jest test. So Jest is just watching for our test. We're going to see. Doesn't look too good right now. It looks like it's infinite looping or getting stuck somewhere. And that was because, look at this one. We're incrementing I instead of J. So J just forever stays where it is. So that now should, I bet Jet, yeah. So my poor Mac does not, my Mac nor does Jess enjoy the fact that I've just infinite looped it. So maybe if I can kill that tab, and then run jest again. Hey, it passed. So just to give you a sense of what's going on, I'm just going to quickly just log the buy price and the sell price. And so you can see we're generating all the different combinations. So you buy at 9, you sell at 11, 9, 8, 9, 5, 9, 7, and the profit is just the difference between the buy price and the sell price. So that's good. That works. But the problem is that this is quite slow in the sense that if we had a huge kind of list of prices, right now, for each, we've got to iterate over all prices, and then basically we've got to iterate from, again, for each price, for all the, prices in front of it. So you can kind of think of this solution right now is going to be, n squared where n's the prices, length of the prices. And we can say that by, if we think of, right, so we said we've got this kind of function here, which is t of n, which just means the time this thing will take, as, dependent on n, where, so we'll say n, where n is the length of the prices, or rather, we'll just say prices.length. We've got to iterate over that, n times, and then for each one here, we've got to do it, it's not n times, it's, for the first one, it's going to be n minus 1, then n minus 2, and n minus 3 as we kind of move along, but we can see that the upper bound there is going to be n squared. So we can kind of look at this as n times n right now. It's not horrible, but we can do better. So we've looked here at this is our first attempt, right? It's a naive solution. It's just the first kind of cab off the rank. And the best part is now that we've got this, we know that it works. We can use that to kind of compare our, optimize, or our, attempts that might be better than this, and kind of compare it to the output. So we can kind of go, sweet, give me, some prices, run this one, which is slow but correct, and then our optimized one, and see if, see if they give the same result. Like we can kind of do correctness that way. So, sweet. So, is there a better way to do this? That's kind of the question now. It's like, sweet, we've got a solution, but is there a better way to do this? And I think there probably is. So let's think. So imagine you're working at a trading firm, and you're not seeing prices like this. You're seeing graphs left, right, and center of all the prices, and bang, a bit of Apple, a bit of Google, bang, the price is always fluctuating. And I think maybe if we look at the prices like that, you might see a pattern or some characteristic of the graph that might yell to us, hey, what if you did X, Y, or Z? So I've just taken the data that we got from the example, like 9, 11, and I've kind of chucked it into a graph, right? I've graphed those data points. And what's interesting is that we know that our max profit here, right, was 5. And that 5 corresponds to the difference between here when we bought it, right? We bought a share at 5 and we sold it at 10, right? So the kind of difference here in height is actually the profit. So the profit corresponds to all the difference in the height of the points, right? If we bought here, if we bought at 9 and we sold at 10, that difference in height of 1 would represent the profit. So it kind of just feels like looking at like, well, what if we just go through, find the lowest point in the graph, right? And then we look at the highest point in the graph, and we go, well, that's our 2 points. But the problem is that if we did that, we would see here, right, that our highest point is 11, our lowest point is 5. So if we just did that, we'd say, okay, sweet. You just need to sell at 11 and buy at 5. But the problem is 11 here is before 5. So no magic will let you sell sell something in the past that is going to happen in the future. So that's no good. But I think that's kind of the right thinking. But another way we can think about it is if we look at, say, this one, for example, right? So I've just generated a random set of data points and just graphed them, 6 share prices. If you look at this share, the difference here is we've got you can kind of think we've got 2 peaks, 2 local peaks in prices. So what we'd like to do is maybe we say, okay, look, let's start at the first price, and we're interested in these segments, right? We're interested in these kind of increase. Now, as long as it's increasing to the right, we know we can make a profit. But as soon as it goes to lower than where we started, we know we're going to lose money. So we're kind of interested in how far can we go, right, before we start losing money, or what's the highest we could have sold at while the price is higher, right? So if we start here at 7, we might look at 12, go sweet, we can still make money on that. All right, 10, not as much money, but we still can make money, but we'll keep track of what's the highest we've seen. Then we look at 13, we say, oh, yeah, that's even better than 12, so let's record that as a profit of 13 minus 7 is 6. Then we look at 9, we say we still could make a profit of 2, but we've already seen 13. And then we look at 7 and we say, well, we could come out with 0, right? We could win or lose nothing. And that would work, and then that's great, but that's assuming that 7 is a low price to start with. So that's not quite right. If we looked at, say, this graph, that wouldn't help at all, because 12 actually, the first price we have is the most expensive. So we don't actually know where the lowest is, but we could just assume that the lowest, where were we? The lowest is at the start, right? And then we can kind of move on, right? So if we assume that the first data point is the lowest, well, it's very possible that there's going to be even a lower data point, than where we started. So if we look at, say, this graph, for example, you can see here that there's actually 3 is lower than the starting price of 7. So we did the same game, right? If we said, all right, let's start at 7 and let's just see how much we can make if we bought the first share. And we look at 7, we look at the next day and we go, all right, it's 12, that's not bad. We could make $5 here. Now, if it goes down to 3, this case we lose 4, right? Because we bought at 7 and we're going to sell at 3, right? So we actually lose $4 here. And the most we could have made is 7 to 12, right? So if we had bought on the first day and sold on the second day, we would have made $5. But if we wait another day till we went up to 3, we'd lose 4. So what we could do is we could say, well, we'll note the fact that if we buy at 7 and we sell at 12, we could make 5, right? So so far we've seen we can make $5. But notice now that 3 is less than 7. So if we're at 7, right, and you wait till the last day and you sold at 8, you make $1. But notice that if you find a data point, if you find a share price that's less than 7, well, if you can make a dollar profit if you wait till the last day and sell for 8, then you're always going to make more money if you can find a cheaper share price. Yeah, maybe I think I'm maybe making it more. I think I'm complicating this a little bit, right? So the idea here is that we say, if I can sell at 7, or rather if I can buy at 7 and sell at 8 and make $1, then it makes sense that if I can find a share price cheaper than 7 somewhere, then I'm always going to make more profit, right? I can buy at 3 and sell at 8 and make $4 more profit. So the idea here is that if I see a lower share price than what I've currently started, what I've started with, I should start looking from there and seeing what's the most I can make, right? Because from this point onwards, the cheaper share price, the cheaper buy price, is always going to make more money than what I started with. I can always change to a cheaper share price and I can just keep track of what I could made at the each previous cheapest share price. So I kind of start at 7 thinking it's the cheapest, and if I see a cheaper one, I'll kind of swap to that and then start looking at how much I could make. So in this case, I could buy at 3 and I could actually sell at 13 with a profit of 10. Whereas if I bought at 7, so yeah, basically to go over it again, what I'm going to do is I'm going to assume a 7 is the cheapest, and I'm going to keep looking at how much profit I can make. So I look at the next day, I see I can sell for 12, so I can make a profit of 5. But then the next day, I actually say I lose. So as soon as I say that I would lose money, right, I'm going to swap. And I'm going to now say that 3 is the cheapest that I could buy it for, and then kind of go, all right, starting at 3, the next day I could sell it for 7, I could make $4. The next day I could sell it 13, I could make $10, right? The next day I could sell it 8. The last day, I could make $5. So if I just looking over these data points, I saw the most I could make was 13 on day 5. So I hope that kind of gives you a feel for graphically what we're going to do. And now we're just going to basically just take that kind of solution and just whack it into a function. So let's have a look. So I'm going to call this max profit 2 prices. And the idea is that I'm going to say, all right, what am I going to say? I'm going to say what I want. I'm still going to do an old school for loop just for now. So I'm going to start at the first price. And I'm still going to have my max equal to 0. And I'm going to have cheapest equal to the first price. Alright, and I'm actually going to start this at 1. And I'm just going to say if prices.length is less than or equal to 1, then return max. Right, because if they've only got one share price, then I can't make a profit on that. All right, so what we're going to do is I'm going to say, all right, let's say prices at I, and I say so basically we want to look at the price and see what profit we'd make if we were to sell at this price. So maybe we'll say cheapest buy price. Oh, let's just say buy price. So we're going to say, all right, so profit here would be buy price, or rather sell price minus our buy price. And I'm going to say if profit, so in this case we want to know when actually we got a new lowest price. So if the profit is greater than max, right, so in this case we've just worked out the profit is the greatest that we've seen so far. We're going to say max equals the profit. Actually, no, we could just say max equals math.max, max and profit. What we're really interested in is if this profit was negative. All right, so if this profit was less than 0, well, if the profit was less than 0, that means we're looking at a data point that's actually lower than what we started with, or what our current buy price is. So we're going to say, all right, our buy price now equals whatever this price is, this sell price, which in this case means that if we're looking at had 7 as our buy price now would be 3, and we're going to, no, that's it, we just move along to the next data point. and then we return our our max. So I'm gonna use max profit 2 and see if that passed, and it did. So that actually, I mean, I wasn't expecting that. I thought it kind of makes me feel something suspect going on that didn't work, but that was the idea, right? So what I've done is I've just got a few more test cases to make sure that it's doing what we expect. And what did it say here? It said that 5, 7, 10 or rather 11, 10, 9. I said 4, but you're right, in fact that's 3. Sweet. So each of these kind of solutions pass, and actually each of these solutions here just map to the each graph that I've defined here in Desmos. So that's good, right? So we've got solutions are working, and we've now got this kind of optimized solution, right? Where we can say the time here, well, here we're doing just one for loop. So it's actually linear time, right? Where n equals prices dot length. So in this case, right, we just iterate over the prices, and we could actually just go, I think we can just go const price of prices. That should still work fine, so got rid of that. If profit's less than 0, we just change our, So in this case, all we're doing is we just do one iteration of the prices, right? So that's now linear time. So it still feels a little bit like magic, like I just, the tests say they pass. So I think we'll trust the tests. But great, we've had we've kind of started with this brute force solution of max profit, and then we've kind of had this refined version where we've kind of looked at the graph and got a sense, and we've looked at the example, we've had a crack at the naive solution, we've now got an optimized solution. Linear time, right? It's not constant time, but it's not too bad. So let's have a look at the solution. So like I said, we're doing daily coding problem number 47. So let's have a look at what they said. All right, so the first thing, I'll just zoom in a little. So first thing they say is they do a brute force solution, right? So very similar idea. We do a brute force solution, buy and sell, they call it, where you iterate over each, same thing, right? I and J, they look at each stock, right, in order, and then for every stock, they go and find the maximum or the best sell price for that particular, if you're going to buy at that particular time. So like they said, this takes up to, this is O of n squared. So can we do better? So what they actually did is they quite cleverly used the fact that if you kind of look at if you move backwards, right, on the graph, you actually can see it's easy. You actually can find the profits that way. So let's take this example, right? So they start here at the back and they say, all right, I'm going to look at 6. I'm going to move backwards over the graph, and I'm going to try and find the lowest price that occurs. So it'll come here at 8, then look at 13. It would say, oh, 13 is the highest I've seen so far, so keep track of that. Now, what's the lowest I can find, right? And then it comes down and sees 3 and says, oh, great. So for the sake of time, I won't jump too much into the solution of their solution, but definitely have a look at it and have a kind of run through here, because it's quite interesting the fact they've exploited that going backwards means that you're sure that the buy price has to come before the sell price. All right, so let's wrap it up there, and I'll see you back here in 2 weeks. Cheers.